see. Hey guys, it's Georgia.
Hi, I'm just Stella.
My name is Julia.
Energy consumption is a huge part of our daily lives. We eat with energy. We travel with energy. We work with energy. And we even flirt with energy. But where does all of this energy come from? Today we gather most of our energy from coal, oil and natural gas, also known as fossil fuels. Additionally, we gather energy from biomass, nuclear and renewables. Fossil fuels consist of extracted decomposed organisms and plants that existed millions of years ago. Biomass converts plants into biometric material to produce energy. Nuclear energy is released during nuclear fusion. Lastly, renewable energy comes from a source that's not depleted when used, such as wind or solar power. But what's the profound difference between them? How they affect our planet? Fossil fuels cost more than what we pay at the pump and impacts our environment in many ways. These impacts include global warming, air quality deterioration, oil spills, and acid rain. It's also projected that fossil fuel resources will be depleted within the next 50 to 100 years. Biomass and nuclear energy also have similar issues. We need a solution relatively fast, and luckily, we have one. Renewable energy comes from resources which naturally replenish in our lifetime, whereas fossil fuels are a one-time use resource in the human timescale. Resources for renewable energy include sunlight, wind, rain, tides, waves and geothermal heat. The best part is that we don't need to compromise our planet to harness it, nor do we have to rely on other nations for these resources, which history has shown to be a contributor to war, famine and political instability. So, how do we get this to look like this? Presently we have the technology to be 100% renewable reliant. The truth is, our infrastructure is built around our fossil fuel dependency. If we could convert our infrastructure to what's known as a supergrid, we would be able to rely on clean, renewable energy. So, what's it going to be? Will our children live in a world full of pollution? Or should they continue the path of evolution? To learn more about a 100% clean, renewable energy future, visit thesolutionproject.org.
Hydropower.
Hydropower, or hydroelectricity, refers to the conversion of energy from flowing water into electricity. It is considered a renewable energy source because the water cycle is constantly renewed by the sun. One of the first uses of hydroenergy was for mechanical milling, such as grinding grains. But today, modern hydro plants produce electricity using turbines and generators. The mechanical energy created by moving water spins rotors on a turbine. This turbine is connected to an electromagnetic generator, which produces electricity when the turbine spins. There are two main types of hydroelectricity production: dams and run-of-river. Hydro dams utilize the potential energy from dammed water to produce electricity. A dam is a large barrier constructed to raise the level of water and control its flow. The elevation created by the dam creates gravitational force for turning the turbine when water is released. Some dams also contain an additional reservoir at their base where water is stored to be pumped to the higher reservoir for release when electricity is in demand. This is referred to as pumped storage hydro. The second form of hydroelectricity production is run-of-river hydro. Run-of-river still uses turbines and generators, but relies on natural water flow rates of rivers, diverting just a portion of the water through turbines. Because run-of-river hydro is subject to natural water variability, it is more intermittent than dammed hydro. There are various sizes of hydro plants that produce electricity. Large hydro, greater than 30 megawatts, small hydro, 100 kilowatts to 30 megawatts, and micro hydro, less than 100 kilowatts. The Hoover Dam in the United States is a whopping 2,074 megawatts, which is enough to serve 1.3 million people. Of all renewable energy sources, hydropower holds the largest share of worldwide electricity production. Hydropower has several benefits. It is a cost-competitive form of electricity, even though the initial building cost can be high. It is quite reliable compared to other renewable options and pairs well with other sources as it can be used as baseload power. In some cases, dammed reservoirs can also help with flood control and be a reliable water supply for communities. There are also some concerns with hydropower, especially when it comes to large dams. Damming a river has a major impact on the local environment, changing wildlife habitats, blocking fish passage, and often forcing people in riverside communities to move out of their homes. In addition, dam failures can be catastrophic, claiming the lives of those living downstream. Hydro plants are also not completely free of greenhouse gas emissions. As with most forms of energy, carbon dioxide emissions happen during construction, particularly due to the large quantities of cement used, and plant matter in the flooded areas makes methane, another greenhouse gas, as it decays underwater. That's hydropower.